we always have a lot of vocabulary. So let's start with what is an experiment? An action. Come on, let me write on this. It was letting me. An action or trial with varying results. Now, what does that really mean? What does that really mean? So let's say very, common in probability. You flip a coin. It can land or heads or tails. That's your varying results. You roll a die. It can land on the number 1, 2, 3, 4, 5, 6. So for example, I'm just going to flip a coin. Just to give you a little example there. Okay, outcomes, which is what we're going to be using today when we go through and actually start calculating our probabilities. A possible result. All the vocab here at the beginning. From the experiment. So an example of that. So I'm going to go back to the flip a coin. If you flip a coin, what are the possible results of flipping a coin? What can it land on? Heads or tails? So I'm just going to put heads. All right, sample space. Now, this to me is kind of like we're splitting hairs here. So a sample space, get ready for this definition, the set of all possible outcomes. Okay. So you might be like, how is this different from the previous one? So, okay, all right. So to give you an example, of course, we talked about I'm using the flipping of the coin. You told me it could land on heads. I'm just going to do H for heads, T for tails. So there's all your possible outcomes if you flip a coin. Get ready. I'm going to put it now as a set. Ooh, if you put braces around it, it makes it a set. Wow, that's very exciting. Am I going to care if you put the braces around it? No, I don't care if you put the braces around it. I just care that you know the possible outcomes would be heads or tails, etc. All right, now this is where we're only going to do, we're not doing all of these, okay? Because like I said, we're really going to focus on calculating probability. This is just some tools to help us. One of them is a tree diagram, and we're going to make one. You probably have done this before. Maybe you just need a refresher. So tree diagram, very useful way of finding the sample space when there's multiple actions. Draw a tree diagram, then list the sample space and determine the number of outcomes for each scenario. Picking a digit 1 through 8, then tossing a coin. Okay, so here we go. So I'm going to start kind of just a dot here in the middle. Now, we're talking about picking a digit 1 through 8. So we're going to have all these branches, 1, 2, 3, 4, 5, 6, 7, 8. Okay, still going, we're still going. So there's my 1 through 8 and tossing a coin. Well, we just talked about this. What are your outcomes for tossing a coin? Heads or tails. So we could have a 1 and then heads or tails. We could have a 2 and then heads and tails. I should have spaced this out or learned to write smaller. A 3, heads or tails. A 4, heads or tails. You get the gist. And I'm still going. Okay, all right. Get your very lovely tree diagram made. Okay, now it's going to ask us to write out the sample space. So set, again, I don't care if you have the braces, that's up to you. Okay, so all of our possible outcomes here, meaning I could have a 1 in a heads, a 1 in a tails. I'm going to just do like 1H, 1T. I could have a 2 in a heads, a 2 in a tails. Fearful I'm going to run out of room here. Okay, 3 in a heads, 3 in a tails. 4 in a heads, 4 in a tails. I'm going to go up top because I'm running out of room. 5 in a heads, 5 in a tails. That's our comma there. 6 in a heads, you got it. 6 in a tails. We're having so much fun. 7 heads, 7 tails. And I'm going to try to cram 8 in here. 8 heads, 8 tails. Ooh. Okay. All right, count them for me. How many total outcomes do we have? 16. Now, questions for you. I don't love a tree diagram personally, because couldn't we just come up with the sample space without doing the tree diagram? I feel like pretty easily. So I don't love a tree diagram, but I'm just showing you that if for a tool, if you need it to help you. What we really care about is the total number of outcomes is 16. I could have calculated that with really hardly writing anything. Here's the next thing we're going to talk about. So if you're picking a number 1 through 8, there's 8 of those outcomes. And then if you flip your coin, how many different possible things can you land on if you flip a coin? 2. And my friends, what's 8 times 2? 16. So I could have told you there was going to be 16 without doing this whole tree diagram and all the shenanigans. So flip to the next page. Like I said, we're not doing all of this. We are going to this fundamental counting principle. So this is easy. It's just very wordy. You know the drill. So this is what we're going to use a lot here. You can use a counting principle to find your total number of outcomes. This is what I just did. I did the 8 times 2. That is this. So if one activity can occur in M ways and the other is in N, we just multiply those together. Just like I did the 8 times 2. Okay, so I'm going to do the exact same thing for these. This is what we're going to use to really calculate our probabilities. Choosing a month of the year. All right, easy question. How many months are there in a year? 12 times 9. All right, here's where you might, you don't need a calculator. You know that. What's 12 times 9? 108. Yeah. Choosing a letter of the alphabet. How many letters in the alphabet? 26. You're doing better than my trig kids. Somebody put 22 down on their test. Really love that. Okay, tossing a coin. How many outcomes on tossing a coin? 2. What's 26 times 2? 52. See, this is easy. I love this stuff. Choosing a pair of pants, a shirt, and a belt from 3 pairs of pants, 5 shirts, 2 belts. What's 3 times 5 times 2? 30. We should just have a test on this. Rolling a standard die 4 times. Okay, let's start with just a single die. How many different numbers can you land on a single die? 6. Okay, and we're doing it 4 times. So it's going to be 6 times 6 times 6 times 6. Big number. What's 6 times 6 times 6 times 6? I don't know about you, but I'm sure glad we don't have to make a tree diagram with that many outcomes on it. Okay, choosing one student from a class of 32 and another from 27. Okay, 32 times 27, what do you get? Perfect. I don't know if we even need to really do all of these, but they're easy, so we're going to come on and scroll screen. We're going to do them all. Sometimes this thing just doesn't like to scroll for me. Okay, spinning the spinner to the left 3 times. Okay, look at the spinner. We're going to see a lot of spinners. How many total different numbers are there to land on your spinner? 16. And we're doing it 3 times. So you have 3 of your 16s. And really, let's talk, what's an efficient way to punch that in your calculator? If you don't want to do 16 times 16 times 16, I would do 16 to the what power? Cube, third. Okay, what do you got? Whew. Glad we don't have to write out all of those outcomes. Okay, tossing a coin 5 times. I swear we talk about a coin a million times. You've already told me there's 2 options, and we're doing it 5 times. Or, of course, you could do 2 to the 5th in your calculator. What do you got? 32. Crushing it. Creating a 4-digit password from the digits 0 through 9. Okay, how many numbers are there from 0 to 9? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 puts you at 10. So we're going to have 10 for each of them. And you're doing a 4-digit password. So 10 times 10 times 10 times 10, 4 of them. For 10 to the 4th. For a final answer of? Got it. All right, let me scroll it down just a little bit here. Choosing, ooh, perfect square. There's some good vocab. That is less than 50 and a letter from the word signature. Well, let's first just list these perfect squares. I'm just going to make a little list underneath. So like 1 squared, 2 squared, 3 squared, 4 squared? 5 squared. What's 6 squared? 36. 7 squared. 8 squared. So I'm stopping. Why am I stopping? It'd be over 50. Okay, so count. How many perfect squares do you have less than 50? 7 of them. And you're picking a letter from the word signature. How many total letters are in the word signature? 9. Got it. Okay, so this is what we're going to use to help us in the next page of notes, which is what we really care about, is calculating probabilities. All right, so let's do that. So probability, of course, vocab, you know we love our vocab in here, is the measure of the chance that a specific event will occur. So for instance, what's the chance if you flip a coin, it lands on a heads? Landing on a heads is your specific event, okay? 50%, you got it. So here's how we're gonna calculate this. This is why we talked about outcomes. We did all of those outcomes in the previous little section. When all outcomes are equally likely, the theoretical probability of calculating, of course, the favorable outcomes to the total. So I know this is on your sheet. I'm just gonna circle it because that's gonna be the calculation we're gonna use. So that total number of outcomes, I'm going to be using a lot of that fundamental counting principle where I'm just multiplying them together. That's going to be easy to get the total, and then we'll have to get into the favorable outcomes here in a minute. All right, probability, your answers are always between 0 and 1. So there's a 0% chance of rain or a 100% chance of rain. And those can be written, and I don't care what style you put them, I'm going to mix and match today, fraction, decimals, or percentages. You pick your poison. I'll probably mix and match. Like I said, it doesn't matter to me. All right, so this is what we care about. We're going to start calculating probability. So you got your spinner, you spin it once, find the probability. Okay, this one they want all of it. Fraction, decimal, percent. Okay, whatever, fine. So first, let's do the easy part. How many total numbers are there on the spinner? 16. So all of our denominators are going to be over 16. I'll just fill it in. That's the easy part, right? Okay, let's do, of course, the top one. So multiples of 3. So multiples of 3 are my favorable outcome. So I'm looking at the spinner. Multiple of 3. What's another multiple of 3? 6. Another multiple of 3. Another. Got it. Anything else? 15. Okay, count them for me. How many total you got there? 5. So 5 over 16. Now, personally, I'm happy just a fraction. I would just leave that. You can't reduce it. But it asks you for the decimal and the percent. So we're going to practice just giving them all here on this first one. Decimal. All you have to do is type in your calculator 5 divided by 16. Punch it in. What do you got? Point what? 3-1. Let's go with. Now, what is 0.31 as a percentage? 31%. Obviously, on a test or quiz, I won't make you give all versions of the answers. We're just practicing. So if you just want to, on a test or quiz, leave 5 over 16, you want to just give me 31%, I don't care. Whatever. Okay. All right, let's do the next one. So prime number. Okay, we got to know what a prime number is first off. What's a prime number? That's why we're going to talk about it. It's only divisible by 1 in itself. So give me an example of a prime number. 2. It's divisible by 1 in itself. What else are prime numbers on here? 5. 7. 11. Anything else? Okay, count them. What about 3? Is 3 prime? Yep, divisible by 1 in itself. So I'm going to kind of double circle that guy. So count them. 6. Now, okay, 6 out of 16, we can reduce that. What's 6 out of 16 reduced to? 3/8, good. So there would be the fraction. Now they just want you to practice. I don't know if we're going to do them all, but let's just practice. What is that as a decimal? What's 3 divided by 8 as a decimal? 0.30. I'm going to round it, 0.38. And then as a percent? 38. Okay. Even or greater than 5. Let's do this one in blue. So even numbers. Let's start with the evens. So 2, 4. 6, 8, 10, 12, 14, 16. Or greater than 5. We're going to have a lot here, aren't we? Okay, greater than 5. Greater, over 5. I already got 6 circled. So 7, 9's greater. Oh my gosh, all of these are greater. Okay, count them. How many total do you have there? 13. Now, does 13 over 16 reduce? No, we're not going to do the decimal percent for everything. Let's just get on with it here. Let's do the next one. Okay, odd. Oh gosh, odd. Now, key word here, and. So it has to satisfy both criteria. It has to be odd and at most 9, which means you can't go over 9. So let's circle our favorable outcomes. Okay, odd and at most 9. So I'm going to start at 1. Is 1 odd and at most 9? Yep, circle it. 2 is not odd. Is 3 odd and at most 9? Yep. 4 is not odd. Is 5 odd and at most? Yep, okay. There's nodding yes. What about 6? No. 7 odd and at most 9? What about 9? It equals 9. We can have that. Okay, count them. You have 1, 2, 3, 4, 5. 5 over 16 doesn't reduce. I'm just going to leave it. Okay, so this is really the rest of what we're doing is these probabilities. And again, I don't know if we have to get crazy and do everything on here because it's more of the same. All right, let's do a couple of these and then we'll do a couple in the back. So a pencil box consists of 5 red, 12 blue, 10 green, and 3 yellow. So first, before we even read the next thing, total those up for me. How many total pencils are in the box? I think I already heard it. Somebody said it. What do you have? Agree. What is the probability it's not yellow? So how many of them are not yellow? 27. See, this is easy. It's just, you got to do a lot of reading. Okay, does that reduce 27 over 30? Yeah, what does it reduce to? 9 over 10. Okay. Like I said, I don't think we need to get crazy and do every single one of these, so we're just going to do a couple more. We'll do a couple in the back. Let's do 3, and then we'll go to the back. What's the probability? Ooh, drawing an ace or a diamond from a deck of cards. Ooh, deck of cards. Okay, first question. Do you know how many cards are in a deck? 52. Okay, next question. How many aces are in a deck? 4. How many diamonds are in a deck? Total diamonds. I think Greg said it. What do you think? 12. There's 12. So total that up. You have how many total favorable outcomes? 16. Now, does 16 over 52 reduce? Probably. They're both even, so that should be a quick yes. Reduce it for me. 4 over... Got it. All right, like I said, I don't think we have to do every single one of these. Flip it to the back. Let's do a couple off of these. All right. Because I feel like these are getting excessively long. All right, let's look at this because I don't know if you've seen a Venn diagram before. Super easy. We're just going to get our numbers off of this, okay? So students in a homeroom were asked if they have a part-time job and if they have their driver's license. Results are shown in the Venn diagram. If a student from homeroom is chosen at random, find each probability. Give each answer as a fraction in simplest form. Okay, let's first figure out what's the total amount of students in here so I know my denominator on my fraction. Total amount of students. How are you getting that off the Venn diagram? If you're guys typing it in, what are you doing to all those numbers? Adding them up. So what's 4 plus 8 plus 6 plus 7? Okay, so I know these are all going to be over 25. I'm going to fill that in. Start with the easy part. Okay, now let's go with the tops. We got to figure out the numerators. So that they have a part-time job. So this entire circle is your part-time job. How many total kids have a part-time job? 8 and 6. So total of 14. Okay, does 14 out of 25 simplify? Nope, circle it. Like it. These are easy, wording. Okay, no driver's license. How many kids do not have a driver's license? I'm with you on the 8. What else? The 4. Those are, they're not in the driver's license circle. So what's 8 plus 4? 12. 12 over to 25 does not reduce. I'm going to circle it. Okay, next. Part-time job and a driver's license. So where do they overlap? 6. The 6 out of 25 simplify. No. Okay, circle it. Let's do the next one. Part-time job or a driver's license. 21. How did you get 21? 21's right. Yep. It's all of those. 8 plus 6 plus 7, 21. See, this is why I don't think you need me to do every single one of these. This is so easy. Driver's license and no part-time job. 7. Does 7 out of 25 reduce? No. Okay, we got it. Let's do this complement. Like I said, let's skip the next one. Let's do the complement. So here's what a complement is. This is so easy. If I tell you there is a 30% chance of rain today, what's the percent it will not rain? 70, because they have to total up to what? 100. So the percentage chance it won't rain, the 70%, that's the complement. Yay, that's what we call it. Okay, so complement of an event is the probability that the event will not occur, so it doesn't rain. Sum of all probabilities, remember, is 1 or 100%. I just did percent this time because I don't know, I felt like it. So of course, to calculate, you just subtract it. Now, just catch, this is just a little mathematical symbol. See this little squiggly guy here? That is your symbol for the complement of the event. The probability will not happen. Okay, this is easy. Let's just do a couple of these. Probability the rain tomorrow is 11 out of 15. What's the probability it will not rain? Yeah, you just subtracted it, right? I don't know why I'm writing work. You can just do that in your head. Okay. All right. I don't think we really need to do any more of those. Let's do the bottom ones, okay? And be done. So you can get your homework done in class. So experimental probabilities based on the results of repeated trials of an experiment. For example, the spinner to the right is spun 50 times. The results shown below. Okay. Notice they have these separated out into theoretical and experimental. So the experimental is you're actually spinning it 50 times. I'm actually doing it. Theoretical is we're just going to kind of look at it and figure out just from the picture without me spinning it, what would be the probabilities. So I'm going to start with the theoretical column. Now, just do a quick count for me over here on our spinner. How many different total options are there? 5. So these are all going to be over 5. Got it. What's the probability that you land on orange? How many sections of the spinner are orange? 1. How many sections of the spinner are red or green? 2. And none of those reduce yet. How many sections are not a purple? 4. So those are the theoretical probabilities. Okay, now we're going to get fancy here, and we're going to do the experimental. Now, notice the experimental, they spun it 50 times. So this is going to all be over 50, which I have a feeling we're going to have to reduce. So orange. So we're going to look at the table. They actually spun it 50 times, and this is what they landed on. So probability it's orange. How many times did it land on orange off the table? 12. You guys can reduce it, whatever. I'm just going to give it to you 6 out of 25. Okay. How many red or greens total? 15. 10 green, 5 red, total of 15. This is ridiculously easy. 3 out of 10. Okay. And the not purple. What's the easiest way to do the not purple? Yeah, I would just do 50 minus 7, which is what? 43. Does 43 over 50 reduce? No, circle it, we're done. That is probability, my friends. Love it.